Welcome back to the Pioneer Room University. I am your urban eco-master, Dr. Covell Rasai Q. McDermott. I'm here in Queens Village, New York, and I'm exploring the urban biolife. Particularly, I'm looking at some plants, some shrubs, some weeds, and the urban trees. Tell you a little bit about their importance in the cities, their ecological functions, the ecosystem services they provide. So today, I want to talk to you about a particular weed, a groundbreaking weed. So this lecture is about to shift the paradigm, shift the way you look at plants and how you view your environment in urban environments. All right? We must not start to practice more biophilic living lifestyle. So in this video, I want to teach you about a plant. Here it is. Now this plant, wow, this is a very tough one. So this plant that I'm holding in my hand, as you can see, it has a taproot that was broken off, right? So this plant, as you can see it, I learned about this plant through my supervisor, my master's supervisor, Professor Satya Raniana Elivati, short Satya Elivati at Delaware State University. Now my people, this plant is very powerful. It is not a medicine now. It has a way more potent use and function in the environment. It has what is called a very powerful ecological function. Now you realize where I pull it up from? This area next to a light pole. So this tells you that it grows in very harsh environment, very tough soil conditions, even in concrete region. Now this plant is called horsetail or morris-tail. All right, so horsetail or morris-tail. The scientific name is Coniza canadensis. Coniza canadensis or horsetail. Now let me tell you something that is very interesting about this plant. This is the very first plant that they found with resistance against Glyphosate-roundup. Yes, this herbicide that was created by chemists, Monsanto chemists, Glyphosate-roundup, that is used to grow corn and soybean. It's in the environment because we use it to fertilize the lawns, right? Now, this plant conferred herbicidal resistance against Glyphosate-roundup in 2001 when it was first discovered in Delaware. Yes, this plant is a pioneering plant. This plant broke the code. This plant evolved epigenetic capabilities. It acclimated to the environment to resist even glyphosate. And as a result, this is a very interesting plant to scientists. Now, I've also debated with this plant during college days. A lot of debates with this plant and Glyphosate-roundup. This plant is special because it is found growing in the harshest environment. Let me tell you something about this plant. If you feel this plant in this area, it is rock tough. This area, very tough. This area is very tough because it is laced with a specific heavy metal, particularly barium and copper. Most barium and copper is in the root area. But this plant is unique because it is used to clean up the environment, ecologically speaking. Wherever you see this plant, it is an indication that area contain a lot of heavy metal. Heavy metals like cadmium, lead, zinc, even the same barium and I said copper. This plant is known to resist glyphosate-roundup. This plant is known to hyper-accumulate a lot of cadmium. Take up a lot of cadmium, bioconcentrate a lot of cadmium, and carry it up into the plant and put it into the leaf and the stem. So this area of the plant contains a lot of cadmium. The leaves contain a lot of cadmium. Now it also contains a lot of zinc and lead. But it bioconcentrate the zinc and the lead. But it hyperaccumulate the cadmium. And it tolerates some amount of copper and barium. Yes, especially in this area, the barium and the copper. Now this plant is used to clean up areas where you have toxic heavy metal spill, or wherever there is heavy metal spill, this plant will appear. Spiritually speaking, it can also be used to identify areas in the environment that needs healing from, such as heavy metal, low frequencies. Now my people, this plant, like I told you, if you want to understand what resilience means, acclimation and adaptation to urban environments, and what are the root mechanisms, what are the biochemical and the physiological mechanisms behind this, let me share a little bit with you. Now for my PhD, my dissertation, I studied some very interesting secondary metabolites in plants. Now, while I was doing my undergrad, I did a comprehensive research where I made some synthetic compounds called di-2-pyridyl ketone, semicarbazone of zinc, cadmium, mercury, and lead. These compounds are chelators. You use them in industrial processes to chelate other heavy metals and remove them. So I was testing their chelating capabilities. They also confer some amount of antimicrobial properties. Now that research project actually inspired me to explore plants that contain similar compounds, but these are now living compounds. So as a result, for my master's thesis and my PhD dissertation, I explored some compounds that chelate heavy metals in plants. And these compounds are called phytochelatins. Now this plant, the root area and the entire plant is loaded with what is called phytochelatins. Now these phytochelatins, my people, let me just back a little bit. These phytochelatins are what the plant uses to take up the heavy metals, take up a lot of cadmium. Now when the plant is taking up a lot of cadmium, so like for example, you're seeing it growing here in the concrete, it tells you that we have a lot of zinc here, a lot of lead and cadmium. These heavy metals are here. Now the root channels, one particular channel in the root channel is what we call the phytochelatin channels. Now the phytochelatin compounds are produced whenever you have the enzyme called phytochelatin synthase. This very interesting enzyme is what is produced in the root zone now and allow for the plant to produce compounds called phytochelatins. And when you look at the compounds like phytochelatin, you realize that they have a unit of glutamyl. They also have an interesting unit of cysteine. Now cysteine is a very important amino acid because it contains sulfur. Now because cysteine is in the phytochelatin, and phytochelatins are made from an antioxidant called glutathione. This sulfur in the phytochelatin is what is used to grab onto the heavy metal. and give the plant this phytochelatin hyperaccumulating capability. Now, whenever the plant hyperaccumulates the heavy metal, such as cadmium, it moves it up the plant and dock it in the leaf and the stem and the seeds and the flower, different parts of it. This is unique capabilities. This is an evolved characteristic. This is epigenetics at work in the city because of the urban conditions. So plants are adapting, acclimating. Now this plant cannot be eaten, cannot be used as a medicine. This plant contains a lot of heavy metal. You use it to what we would call it bio-identify different areas in your environment that contains heavy metal, and then you plant this herb or allow this weed to grow for what we call phytoremediation, right? So you can use it in remediation work, like use it to clean up the soil, clean up the environment. Just plant a lot of this and it takes up the heavy metals and clean up the area from the heavy metal. And remember, where you have heavy metal in the soil, if you have a heavy metal spill or any toxic spill, that environment tend to harbor new microorganisms, heavy metal eating microorganisms to that particular area as well, and change the ecology, the biodiversity of the area. So heavy metals can influence the ecosystem in negative ways. But we have plants like these in the urban environment that are here to clean up the environment as we go along. So don't just regard them as weed and just think that they have no purpose. They have significant purpose. In fact, when you study weed science, they will teach you that a weed is a plant that grows where it is not wanted. This means that the definition is operational. If you're planting a field of pure corn and tomato comes up, tomato is a weed. So let us consider these plants as important biotypes in the urban environment because they are carrying out very important ecological functions such as sequestrating carbon dioxide, the excess carbon dioxide in the urban environment, reducing the temperature when it does that, putting back some of the carbon, the invisible carbon dioxide, back as soil organic carbon into the soil. So over time, improving the urban soil, because urban environment is one of those environments that are very unique. They don't have the typical sand, silt, clay, and loam soil. Soil in urban environment are called anthrosol because they are formed from anthropogenic activities, human influence activities and actions over time. So you find that the soil in urban environment contain a lot of rubble, debris, toxins, all different type of things come together to form the soil over time. But these plants are here, naturally attracted to the urban environment. The urban environment, because of the excess CO2, the heavy metals, the nitrogen deposition, urban environment becomes harbingers, and these plants are attracted to help clean up the urban environment and the urban soil. So next time you see this plant, this is called horsetail, Coniza canadensis. So much plant is inside of my head, my people. Next time I tell you some more about this plant. This plant is called foxtail, but I want to tell you some more deep about this type of foxtail, alright? Alright, take care. Thanks again. I'm out.